All right, here we are again. Or maybe it's your first time. Doesn't really matter, but here we are. This video is going to discuss different ways or a way to solve most of your engineering statics problems. It's grouped up into different phases or items. The first is the problem statement. This is the statement that you're given in your textbook or on your exam, or maybe your teacher gave it to you. However you look at it, most of them can be solved or has some sort of problem statement to it. This has to be read multiple times in order to gain clarity on what is being asked and what is being given. For instance, for this case, the force F, so you're already given some F, and that is the constant, and that has a magnitude of 6 to 100 newtons at an angle of negative 40 degrees. So you know that you have magnitude and now you have direction under a certain framework you have to think about. From the x-axis, okay, that's given a direction. Express F, so this is part of the find that we're looking for, as a vector in terms of unit vectors I and j. So there's already some understanding and assumptions outlined in this that will come later. And we want to identify the x and y scalar components of F. It's not a very difficult problem or complex at this level, but it does pose some interest. So let's start to solve this and let's start writing this out. So first and foremost, we want to take in all the givens. And I don't mean rewrite the problem statement. That's not what I want you to do. I want you to assign constant letters to numbers so we can use them in the problem. For instance, the first one's already given to us. So it says in the problem statement, the force F. So what we can say is F is equal to 600 newtons. That's all we'd write for the given. Again, we're extracting a lot of the information. And we also want to say that the angle is negative 40 degrees from the x-axis. What angle? Well, we're going to assign that just as an alpha. And we can assign it negative 40 degrees, or we can assign it 40 degrees. And we can say the find is negative later, and we can draw, when we illustrate this problem, a negative 40 degree angle. Just to let you know. But what we're going to do is we're going to say that this is a negative 40 degree angle from the x-axis. All right. So is that everything that's given? Well, in reality of this problem statement, yes, it is. There is more that's given in this problem, but that's all we need to start to look and find our solution. Next, we want to describe the find. And the find illustrates in some sort of algebraic term, some letter usually, or some Greek letter as well. And we want to find the I and j vector units in term f. So what we can say is, we can say fx we want to find, and that is in the I direction, and fy is in the j direction. So these are the unit vectors that we'll find, or the magnitudes of the express f. So we want to find the scalar components of f. So fx and fy. X is given, it's the y in the I, and the fy is given to the j. Now, assumptions of this. One thing is we can assume that since this is just math, we can say that we are in Euclidean space. That's one thing that we can say about this. We are in Euclidean space. We're not in some abstract space. This is some vector space. And we can assume that because we don't really know anything else at this point. Also note that we can use linear vector geometry for this. So now comes the illustration. The illustration is basically drawing that represents. So this is very important you get this right. This is highly important you get this right, because if you get this incorrect, your solution will be incorrect as well. So let's draw this and let's see what we come up with. So we have first, it also said, gives us some direction. So we know that we need to draw some sort of framework. And that's what we're assuming, that we have some framework, and we can say that that's in the y, and this is in the x. Now we could rotate this, but this is our standard terms. And then it also says, if we go back and reread the problem statement, so let's look up here and see what we have the problem statement. We have a magnitude of 600 newtons, but we're going to express that in the illustration as an f. And we're going to use this alpha to negative 40 degrees. So what we want to do is, we can, if you have the capability, it is better to have, in my opinion, to have colors in this to represent different things. So basically what we're going to do is we're going to say this is f. All right, that is, and it's some degree, right? No, that's not a good color. Let's go with more of that color. And we're going to say that that is alpha, knowing that that is negative 40 degrees. So basically, now what we can do is, we know this is given. But what are we trying to find? So we need to outline that in the, let's go with a nice yellow here. We know that we want to find the fx component. So that's there. We can say that that's fx. And then we also have an fy component. This is even before we even begun with the solutions. So if we continue on down, now we can we have some sort of outline to look at our solutions to this. So our solution to this, well, let's put solution. Let's change the font size a little smaller. That's good. And it's good to know. Now, what does a solution look like? First, there's no really general equation for this, but what we can know in this case, we can say that f of x is equal to what with the two givens? So we can say that f of x is equal to f magnitude times the cosine of alpha. Now here's the thing. F of x is what we're looking for. This is, like I said, a simple problem. We know f, right? And we know alpha. So we've already solved for this in algebraic terms. So that's good. Next, we could say that fy is equal to f the sine of alpha. Now what I'm going to do is I'm going to put a little semicolon next to this. This is a matter of style for myself. Not everyone does this, but it sounds pretty good. And we can say that 600 times the cosine of negative 40, we know that it's going to be equal to 459 newtons. So this is the answer, but we're not done yet. And then also we know that 600 times the negative sign is going to give us a value of negative 385.6 newtons. Now it depends on your teacher, but usually it's about 4 significant digits. So those are the kind of the answers. So now what we need to do is we need to wrap this up. And we can say, you guessed it, answer. Some call it a result. I call it an answer, but you can call it however you want. And again, this is one way to solve problems. Now we can say that f of x is equal to 459 and f of y is equal to negative 386 newtons. So again, that is our answer. We can a box may help, depending on, like I said, depending on your teacher. But knowing that this is a general flow of how to solve statics problems with an example. And the answer is just the numerical value. Sometimes it's numerical. Sometimes it uses equations. Other times it uses units. Again, what I would do it also, now rechecking this, I would say, oh, this student got it wrong. And it would be worth some points. But why is it wrong? Because we did not have the value of Newton. And that's highly important when we're talking in engineering terms. I hope you learned something and keep working.